Hello students, today I am going to discuss Cambridge IGCSE Chemistry October-November 2023 paper 41 question 4 to 6. Let's move. Number 4, aqueous hydrogen peroxide slowly forms water and oxygen at room temperature and pressure RTP. RTP means room temperature and pressure. This reaction is catalyzed by manganese 4 oxide. This equation is hydrogen peroxide break down to form oxygen and water. So number A, state the test for oxygen gas. How can test for oxygen gas? And test, a glowing splint is placed on the gas. Observation, you will see glowing splint relights. Oxygen relights a glowing splint. This is the test for oxygen. Then number B, a student investigate the rate of formation of oxygen gas when manganese 4 oxide is added to aqueous hydrogen peroxide. The volume of oxygen gas form is measured at regular intervals at RTP. The result are plotted on the graph. This graph you see, this is the volume of gas increases with increasing temperature, with increasing time. From this graph we can see time is increasing, so volume of oxygen gas also increased. Then you see number 1, state how the graph in figure 4.1 shows the rate of reaction at time t2 is lower than at t1. You see t1 less time graph is more steeper, and t2 more time graph is less steeper. That means t2 gradient is lower. Gradient lower means rate of reaction is less. So lower gradient at t2. Then number 2, explain using collision theory why the rate of reaction at t2 is lower than t1. t2 is lower, you see t2 gradient is lower, that means rate of reaction is less. So why this? At t2 concentration of hydrogen peroxide particles decreases, so frequency of collisions between particles decreases. As t2 concentration of hydrogen peroxide is less, so less effective collision occurs. That's why gradient is lower. Next, you see number 3, on figure 4.1, sketch the graph obtained when the experiment is repeated using aqueous hydrogen peroxide at higher temperature. And higher temperature rate of reaction will be higher, so graph will be more steeper, but total volume of gas oxygen will be same. All other condition remain same. So at higher temperature, you see graph will be at higher temperature graph will be more steeper, but volume of oxygen gas will be same because temperature increases the rate of reaction. How? Increasing temperature, the kinetic energy of the molecule increases, more molecules gain energy greater or equal than activation energy, so more successful collision occurs. That's why rate of reaction is increased. Next, this is chemical calculation. Number C, manganese 4 oxide is added to 20 centimeter cube of aqueous hydrogen peroxide. Hydrogen peroxide volume is given 20 centimeter cube. The total volume of oxygen gas produced is 72 centimeter cube at RTP. So volume of oxygen is given. This is equation. Calculate the concentration of aqueous hydrogen peroxide in gram per dm cube using the following steps. So you see, first, as oxygen volume is given, so we will use gas formula. Calculate the number of moles of oxygen gas produced. Moles of oxygen volume divided by molar volume. Volume 72 centimeter cube, molar volume 24 dm cube or 24,000 centimeter cube. As here centimeter cube is given, so I write here 24,000 centimeter cube. So if you calculate, you get 0.003 moles of oxygen. Then determine the number of moles of hydrogen peroxide which reacts. You see, oxygen 1 mole, hydrogen peroxide 2 mole. This means moles of hydrogen peroxide is double of moles of oxygen. So moles of hydrogen peroxide, moles of oxygen times 2, 0.006 mole. Then next, calculate the concentration of aqueous hydrogen peroxide in mole per dm cube. And you know, number of mole equal N equals Cv, concentration times volume. So concentration equal N by V, number of mole divided by volume. So CONC means concentration. Concentration of hydrogen peroxide, number of mole 0.006, volume 20 is given in question. So V 20 centimeter cube, so we will convert it to dm cube by dividing 1000. So concentration of hydrogen peroxide, number of mole divided by volume, 0.3 mole per dm cube. This is the concentration of hydrogen peroxide. Then next you are asking, calculate the concentration of aqueous hydrogen peroxide in gram per dm cube. So you know formula, molar mass mR, relative molecular mass, equal concentration in gram per dm cube divided by concentration is in mole per dm cube. So concentration of gram per dm cube will be cross multiplication, concentration in gram per dm cube divided by concentration in gram per dm cube equal concentration in mole per dm cube times relative molecular mass mR. So mR of H2O2, hydrogen 1 times 2 plus oxygen 16 times 2, 34. Now concentration of H2O2 in gram per dm cube, is asking here. So concentration in mole per dm cube, already you calculate 0.03 times relative molecular mass, H2O2 relative molecular mass 34. So 10.2 gram per dm cube. This is the answer. Next, D. Suggest the identity of one other metal oxide who is also catalyze the reaction. And you know, transition metal oxide used as catalyst. This V2O5 vanadium 5 oxide is used as catalyst for the manufacture of sulfuric acid in contact process. So V2O5 the answer. Next, this number 5. Methane reacts with steam to produce hydrogen gas. Methane reacts with steam means water gas, to form carbon monoxide plus hydrogen. Delta is positive 200 kJ per mole. That means this is endothermic reaction. The reaction takes place at 1000 degrees centigrade and 100 kilopascal pressure. So number A, the reaction is reversible and reaches an equilibrium in a closed system. State two features of an equilibrium. State two features of an equilibrium. Number 1, the rate of forward reaction equals the rate of reverse reaction. Means the rate of forward reaction and the rate of backward reaction are equal. Number 2, the concentration of reactants and products do not change, or concentration of reactant and product remain constant. Okay, but you don't write the concentration of reactant and product remain same, not same, you write remain constant. Number B, state and explain in terms of equilibrium what happens to the concentration of hydrogen when the pressure is increased. So if pressure is increased, concentration decreases because position of equilibrium shifts to left as fewer moles of gas on left hand side. Pressure is increased. Okay, you see, if you increase pressure, left side has 1 mole, 2 mole total, right side 1 mole, 3 mole, total 4 mole. So if you increase pressure, equilibrium will move from right to left. So concentration of hydrogen decreases. Now you see the answer. The pressure is increased, so concentration of hydrogen decreases because position of equilibrium moves right to left or shifts to the left as there are fewer moles of gas on left hand side. Now you see number 2, the temperature is increased. As this reaction is, you see, delta is positive, so left to right is endothermic reaction. So if you temperature is increased, equilibrium will move from left to right. So concentration of hydrogen increases, because position of equilibrium shifts to the right as the forward reaction is endothermic reaction. Then number 3, a catalyst is used. So catalysts have no effect on the concentration or yield, so no change, because catalysts do not affect the position of equilibrium. Catalyst only speed up the reaction, but it has no effect on the position of equilibrium, so hydrogen will remain same. Hydrogen concentration do not change, remain constant. Next, number C, methane is a greenhouse gas which contributes to global warming. 1. Name a greenhouse gas found in clean dry air. Carbon dioxide. Carbon dioxide, 0.03% carbon dioxide is present in air. So this is a greenhouse gas, carbon dioxide. Now number 2, explain in terms of thermal energy how greenhouse gases cause global warming. How greenhouse gas causes global warming. And greenhouse gases absorb thermal energy. They absorb energy from the sun absorbed by the earth surface. Earth release this thermal energy. So this is the cause how greenhouse gases causes global warming. Greenhouse gases absorb thermal energy from the sun absorbed by the earth surface. Earth emits this thermal energy. Next, number 6, ethanol is manufactured by 2 methods. Method 1, fermentation of aqueous glucose. Method 2, catalytic addition of steam to an alkene. Method 1 takes place at room temperature and pressure. State 2 other condition needed in method 1, and method 1 fermentation enzyme is needed. Enzyme is yeast which contains zymase enzyme. So one condition is yeast and absence of air. Air should be absent, because if air present, then alcohol oxidized to carboxylic acid. B1, state the typical temperature and pressure used in method 2 and method 2 catalytic addition of steam to an alkene. Temperature 300 degrees centigrade, pressure 60 atm. So 60 atm, if you convert it kilopascal, this will be 6000 kilopascal, because 1 atm equal to 101 kilopascal. So this will be 6000, close to 6000 kilopascal. Next, name the alkene used in method 2, ethene. Ethene reacts with steam to produce ethanol. 3. State why the reaction in method 2 is referred to as an addition reaction, because it produces only one product. In this method, only one product is produced. So this is addition reaction. Then number C, the catalyst in method 2, the catalyst in method 2 is phosphoric acid. Dilute phosphoric acid is a weak acid which contains phosphate ion. Number 1, state what is meant by the term acid. Acid means proton donor. Acid donates proton. Number 2, state the meaning of weak in the term weak acid. Weak means partially dissociates, or weak means partially ionizes. Number 3, determine the oxidation number of phosphorus in phosphate ion. So phosphorus, you don't know, phosphorus is P plus 4 oxygen. 1 oxygen is -2 times 4 equal total power -3. So if you solve it, phosphorus 4 to the 8 3, so phosphorus here plus 5. Oxidation number of phosphorus in phosphate ion is plus 5. Next, give one advantage of each method of production of ethanol. Advantage. So method 1 means fermentation, uses renewable resources. Renewable means which can be renewed. Say sugar cane is a renewable resources. Method 2 advantage is rate of reaction is high rate of reaction. This is the advantage of hydration. Ethanol can be converted to ethanoic acid by reacting it with an acidified oxidizing agent. Name the oxidizing agent. This is potassium manganate 7, or you can write potassium dichromate. Potassium dichromate and potassium permanganate are two common oxidizing agents. So state in terms of redox what type of reagent ethanol in this reaction. So ethanol is a reducing agent because reducing agent reduces other substance but itself oxidizes. So ethanol oxidized to ethanoic acid reduces potassium permanganate to manganese 2. That's why ethanol here acts as a reducing agent. Then next, F, ethanoic acid reacts with calcium to form a salt and one other product. Name the salt. Calcium ethanoate. And you know, carboxylic acid metal reacts with carboxylic acid to form metal salt of carboxylic acid plus hydrogen. So, and write the formula of this salt, calcium ethanoate, CH3COO ethanoate. These two, because calcium valence is 2 as calcium is a group 2. And number 3, identify the other product. This other product is hydrogen. Other product is hydrogen. Carboxylic acid reacts with metal to produce metal salt of carboxylic acid plus hydrogen. Thank you dear students. Please subscribe, like and share my channel. Thank you.